Okay, hi guys. My name is Longdi Zhang, and my student ID card is 5156404. Okay, this one. Okay, let's start my presentation. Here's my presentation about historical simulation and module building in the estimation of a VaR. What is a VaR? VaR, which is a value at a risk, referred to the maximum amount of money that can be expected to be lost over a given period of time and a given confidence level in part A of the assignment. I use two approaches to analysis of a VaR. One is a historical simulation and another one is a module building. Okay, going on. Historical simulation refers to the calculation of the current portfolio rate of a return based on the historical return data of each asset, rank historical returns from lowest to the highest. So the rate of a return at a confidence times n is the estimation of a VaR. The historical simulation method assumes the market variables following the distribution given by the historical data. In part A, I use the following result shown on the slides. These slides, the interpretation is quite straightforward. If we invest 10 million in portfolio, we would expect there's a 1% chance of losing 1,221,945.83 or more in this investment. If we invest 10 million in portfolio, we would expect it is a 10% chance of losing about 460,000 or more in this investment. Okay, so the advantage of a historical simulation is a simple method of generating scenario. It is relatively easy to calculate day-over-day change in the market data and apply them to current market data. Secondly, all historical mean value, volatility, and correlation are embedded in historical data itself, and module including them without any extra effort. Third, there's no need to assume to distribution for data. The final one is popular and easy to explain. Going on the disadvantage, first, we assume the historical data will repeat, which may not be realistic. Second, the period user may contain extraordinary events such as a financial crisis, which may also not be realistic. So the one-day VaR is often scaled up to the n days by simply multiplying the one-day VaR by the square root of n. Scaling this way also neglects portfolio efforts. Fourth is a slowly method and cannot easily incorporate volatility updating schemes. Okay, going on the module building approach. Is different from the previous method. The module building approach assumes the market variable following the multivariate normal distribution. The result I get in part A is the following. The interpreting is if we invest 10 million in portfolio, we would expect there's a 10 chance of losing about 810,000 or more in this investment is higher than the historical simulation. If we invest 10 million in portfolio, we would expect 1% chance of losing about 1.46 million or more in this investment. Is a lower than historical simulation. We can see the distribution of two methods is quite different. One following historical distribution and another follows a normal distribution. The advantage of a variance or covariance method is fast and simple. And second, there are less historical data required. The disadvantage of a reliance on the normal distribution assumption, which might not realistic. Second, assume a historical correlation are stable, which might not realistic. The next, large chance in the price of a financial instrument is not considered. The final one is not easy explain and not popular among investors. Okay, to sum up, VaR is quite useful in the financial trading. First, it makes risk of financial activity comparable. Secondly, VaR market risk variable in monetary terms. The final one is VaR considers the relationship between the different risk factors. Okay, that's all. That is my presentation. Thank you for your listening.